we've been doing the residential wiring on all of the Habitat, Central Berkshire Habitat for Humanity houses for at least the last 10 years. We've probably done approximately 16 to 17 homes since we started. The one thing I just wanted to take a few minutes to talk about is what it takes to become a licensed electrician in the state of Massachusetts. What the state requires is you have to have 600 hours of class hours. So that can either be from a trade school or such as locally here, McCann Technical High School offers night classes. It takes approximately 4 years if you're going 2 nights a week to get those 600 hours. And then also on top of the 600 hours, you have to have 8,000 hours of work hours under a licensed electrician. So a licensed electrician has to be working with you at all times. So 8,000 hours is 4 years full-time, 40 hours a week. So typically, before you can even go and take your state license exam, and you have to pass that exam to become licensed, you're looking at about the shortest time is 4 to 5 years that someone can attain all of that training, and then they can become licensed, and then you can work on your own in the field. To become a master electrician, you have to take an additional 250 hours of classes, which is both the electrical field, code, and also business related. And then also an additional 2,000 work hours you have to work as a journeyman electrician before you can go and take the state exam to become a master. So it's a commitment. It's similar, very similar to a 4-year degree or even a master's degree going to college. So the skilled trades are, they're very technical, a lot of training, a lot of experience before you can become licensed. In Massachusetts, I believe for a journeyman electrician, there's different rates. There's union rates, and then there's also just non-union rates. But a typical electrician with no overtime can make $65,000 a year, just a regular journeyman electrician. A lot of the rates are into the $30 an hour, which is 60,000 and above. Some of the union work is even higher than that. And then if you get into working Saturdays overtime, you can make a very, very good living, equal to college education, many times even above. Benefits for the union benefits are great. Even for a lot of the smaller contractors, offer 401k plans, health plans. So it's a very good career to get into, excellent career. I would advise any younger people to get into it. The average age of a licensed Massachusetts electrician right now is 55. So many of us are retiring right now, and there's going to be a large need for new people coming up to fill those slots. Same thing with plumbers. The average age of a licensed plumber in Massachusetts is 55. So there's going to be there's a great need right now, and it's going to become even more so in the coming few years. Okay, these are receptacle boxes. So in a residential home, there's requirements that they have to be no further than 6 feet away from a receptacle box is the greatest distance along the wall. So that means every 12 foot you have to have a receptacle box, or if there's a 2-foot wall, you have to have a receptacle box. And that's like lamps, they all have 6-foot cords, so there's no need to use extension cords, which are dangerous. The boxes are mounted approximately 15 to 16 inches off the floor on center. What we do is we cut a piece of board that is this dimension from here to here, and then just set the box on it, and then nail the box to the side of the stud. Then what we do, once all those are in place in the room, we drill holes through approximately a foot above the box. As you can see, there's one here, and that's where the wires will be pulled through the wall and then into each box. And then there's a wire that will jump from between the boxes. And for this, it's a bedroom. It's going to be all one circuit. We'll be mounting a switch box here for the light when coming into the room. The door will be swinging away, going that way, and there'll be a switch box here to turn the lights on. And that's pretty much, there'll be a ceiling fixture for the lighting in the room. And pretty much for a bedroom, that is the typical electrical in a bedroom. My name's John Levesque. I'm with Ram Electrical Services. And just to give you a little information on another aspect of electrician's work, electrical work. We are currently in a medium voltage substation, and we'll be showing you some other video of equipment within this substation. This circuit breaker, you have circuit breakers in your house, in your electrical panel. This is a medium voltage circuit breaker. It's good for up to 15,000 volts, 1,200 amps. So in electrical substations, this is, it's a very old one. It's oil filled, and there's contacts inside. This whole circuit breaker lifts up into the substation gear and makes contacts. So there's, on this substation here, it's 13,800 volts is what comes in, and that's considered medium voltage. So when these breakers are inside the gear, the substation gear, it opens and closes the circuit that goes out and feeds other lines. Shortly we'll be showing you some of the 115,000 volt, which is on the other side of the transformers, feeding the transformers, which then feed on the low side of the transformer, which is 13,800 volts, feeds these breakers. So this is just another level of electrical work that you may be interested in. This equipment here, they're lead acid batteries. It's called a battery rack. And what these are for in a substation, all substations have them, they supply the DC power. It's 130 volts. They supply the DC power to be able to open and close the large 13.8 circuit breakers. There's also, they call them trip relays, that sense the current on the electrical lines that then send the signal to the breaker to open up if there's a fault. So these battery racks are critical to the operation. If these batteries weren't in operation or something went wrong with them, the breakers wouldn't open, and then you would have a catastrophic fault. This equipment here is a newer style circuit breaker, a little bit newer style. It's called a MagnaBlast circuit breaker. This one, there's no oil in it. It's all done with arc chutes for when the breaker opens and closes to extinguish the medium voltage arc. But you can see it has the same contact bushings. There's the line, which is on the front, and the load side is the back, if it's a load breaker. But it's all, it's a large magnet, and that's what causes, with the 130 volts DC from the battery rack, it's a large magnet that closes the breaker. And then it's all spring loaded, so when it opens, the springs quickly open it so it extinguishes the arc quickly. This is a typical substation switch gear. It's called metal clad gear. So in a lot of utilities substations, this is old gear. So the more modern looks a little bit different. But this is what a substation typically looks like. All these black boxes that are in the doors, those are all the trip relays. So those are sense the current on the lines going out, and they'll trip the breaker if there's a fault. So that's what senses the current and sends the signal to the breaker to switch. There's 13,800 volts that's inside of this metal clad gear that's feeding circuit breakers. Each one of these doors, there's a circuit breaker inside that receives power from the main transformers and then goes through the circuit breaker and then goes underground going out. If it was a utility, it would be going out and feeding all the streets out in your community, power going up on the telephone pole. For the electrical trades, there's a huge amount of maintenance that's required to maintain this type of equipment. The breakers have to be tested quite frequently. They have to be cleaned, maintained. All of these relays have to be cleaned, taken out and tested to make sure they trip correctly, so that if there is a fault, it doesn't cause catastrophic failure. We're currently out in the switch yard, the high voltage switch yard. There's the high line transmission lines that come in from the utility. This substation, the power coming in is 115,000 volts, 115 kV. So the power comes in off the transmission towers, goes through a 115,000 motorized switch. So it's three-phase, so you can see the three lines. And then you can see there's rods that are probably about 1.25 inch diameter aluminum. When that switch is operated, those arms, the rods, lift up and disconnect the transformer. In back of the switch, you can see that's a 15 kVA, 115,000 volt to 13.8 thousand volt transformer. The high side, the bushings that you can see up on top, they're about 5 foot tall. That's the 115,000 volt primary side, and then it drops down, the transformer drops that voltage down to 13.8, which then goes in and feeds the breakers in the substation. Very different from residential work, and very different from even commercial, industrial manufacturing. A big part of working in these areas is safety. Safety is huge working in with this type of equipment, because there are no second chances. If you're making a mistake, chances are you will not survive that mistake. We're now going to show you some of the clothing that's used to be able to work on some of this medium voltage and high voltage equipment. What I'm wearing, the suit, is called an arc flash suit. It's used, we use it for testing. Anytime we're testing lines to make sure they're off. And then also, anytime you work with this type of equipment, you apply workers' grounds before you actually come in contact with any equipment. So you actually ground things out to make sure it's safe. You'll see a lot of utility companies, they actually work live. So they'll have their electrical gloves on, and they'll actually be handling the cables live, or they'll be using the hot stick, which I'll show you shortly. This is actually a very high rated arc flash suit. It's 100 calorie. Normally the highest you'll see is about 40 calorie, because calories are the amount of heat, if there's an arc flash from the electric, if something shorts out and you get that arcing blast, which is thousands and thousands of degrees Fahrenheit, so it doesn't burn you. So when we test the equipment to make sure it's turned off, it's dead, this is the type of suit we would wear. We would also have a hood, another light hood, a baklava over our head. And then over that, we would place this, so it's almost, it ends up almost being like a moon suit. This goes on. Then you put your electrical gloves, which are rubber with leather outers. And before you go near anything that you're working on, after it's been shut down, what you do is there's a non-contact tester that it's audio, and there's a tester. So if you put this here, that's the sound that you'll hear if things were actually live. So I'm testing it right now. Then what you do is you take your hot stick, which is this piece of equipment. It's all made out of fiberglass. It's insulated. And this tester just goes on the end of the hot stick, and then you would lift this up towards whatever equipment you want to prove that it's not live. So if you hear that sound goes off, that would show that it's still live and you don't want to go anywhere near it. Once you prove that the power is off, you retest the tester to make sure everything is still working, that the tester is still working. Then what you would do is you would connect your ground clamp to the end of the hot stick, and then you would take this and put it on the wire and then tighten it down. You can actually turn this hot stick, and there's a screw, and that tightens down on the wire and then applies. The other end of the wire would be tied to ground, so that you know that there's absolutely no voltage left on the line. And these type of practices, these safety practices, are critical. They must be followed at all times. In these suits, it gets very hot, especially during the summer months. You know, you can probably only work in this type of suit maybe for about 15 minutes, and you have to get out of it. It just gets too hot. They do make some we have one that has a cooling fan in the hood, so at least you're getting fresh air cooling. But even with that, during the summer months, it gets very hot.